Hello, everyone. Welcome to our session. Hope everyone's enjoying the reInvent so far. So my name is Mark Stevens. I'm a partner solutions architect with AWS, and I'm also a global segment leader focused on media and entertainment. I'm here with Hilary Roschke from Discovery and Jaime Valenzuela from 20th Century Fox. So we're going to talk about modernizing media supply chains. And so the first question is why the AWS cloud? And so, what we always encourage at AWS is customers to do more, and to do more with less risk, though. So we like to encourage customers to do experimentation. So if it's a serverless architecture, if it's containers, we want you to go and spin up a bunch of servers, try things out. We want you to go and tag the infrastructure, see how much that's costing you, and then if things work out, great. If they don't, shut it down. There's nothing lost there. You can compare this with on-prem, where if you're doing a project, you're purchasing a bunch of hardware, you're installing that hardware, you've got some lead time of many months, and if that doesn't work out, you got to try and repurpose that hardware. So much less risk in the cloud. And so what we like to do is we like to tell stories about customers and about partners. And to us, it feels like we're standing on the shoulders of giants. With someone like Discovery and Fox. We like to bring them up here and have them tell stories. And the other thing we find interesting is that in the community, all these different companies are looking to each other to see what can be accomplished and what's going on, so they can get some direction as well. So we find this works really well. And so why the push to modernize? So the first thing we hear from customers and even partners is media companies want to understand their customers. So they want to understand what the customers want and what they need. And the second thing is they want to focus on the experience. So it's how do you differentiate yourself as a media company? Because at the end of the day, everyone's fighting for your time and for these hours in the day when you're watching content. And then the next thing is building that reach. So how do you go beyond your national market? And so if you're an HBO or a Netflix and you've got the rights to your content, if you're on-prem, it's a little harder to build and kind of go global. But if you saw the way, for example, Netflix just kind of went global through automation, that's something that's very easy to do in the cloud as well. And so, what do you have to do to modernize? And so if you think about, I was at a large media company for a number of years. It went from tape-based to SD-based to HD-based, and then to 4K. And when you look at those transitions, there's a lot of things you have to do. And so the next thing you have to do is you want to instrument, capture, and process data. And so again, there's a lot that you have to do with your architecture and your infrastructure to capture that data, to process the data, and to get insights, and then to take action. And the last thing you need is these agile workflows in order to make this whole process complete. And so again, the cloud is more dynamic for you. You're not constrained by hardware or bandwidth. It's really up to your imagination what you can build. The thing I like too, being a developer for many, many years, is developers love that control. Builders love to be able to just come in, spin up infrastructure, automate it. Again, if things don't work out, spin it back down. It's very easy. You're not waiting on access. You're not waiting on someone to install servers. So how are things being built? So, we have a number of native services I think most people are aware of. Things like compute, things like networking, things like Direct Connect, EC2, Lambda, ECS. I think a lot of people are familiar with these things now. But the other interesting thing is some of our other native services like AWS Elemental. So, Jaime and Hilary are both going to get up here and talk about their supply chains, but they're also going to talk about things like Media Convert, or translate or transcribe, or recognition, where you can get a lot more metadata out of your content really easily with these cloud native services. Right? These are things you don't have to deploy on-prem and don't have to manage. Of course, the other thing is machine learning, and that's where transcribe and recognition and those sort of services fit in as well. The other interesting thing about recognition and transcribe is this is where companies trying to get more metadata from their content for monetization, right? If you can't find the content, you sort of can't monetize it. The other thing we hear from customers a lot is they've invested a lot in their on-premises hardware, but they want a path to the cloud. So whether you're visual effects and rendering and you're out of capacity, you want to burst to the cloud, or supply chain, you can mirror what you have on-prem. We also have the same partners that you had on-prem in AWS. And with the cloud, you can build these global workflows. So being a partner guy, we have the largest M&E partner community. We have this vast ecosystem of partners, Vitaspine, Telestream, SDVI, Arditto, Hybric. I mean, you tell us the partner you're using, and we can sort of tell you where they are in the cloud journey. So there's a Vitaspine who's sort of cloud native. They grew up in the cloud. You have other partners that are starting their cloud journey. They're in one of a few different states. We're here as a partner team to support them. We do well-architected programs with them, and it's really a long-term journey. And what we do is we really try to accelerate their knowledge by working with many media companies. So in the cloud, you want to build agile, and you want to build for the future. So if you think about what you have on-prem, you probably have multiple systems for processing your content and sort of a repeat of your supply chain. And the interesting thing in the cloud is now you can have one supply chain that sits in the middle. You're going to use cloud-native services, and you have logic that knows, or business rules that dictate where that content's going to go. So you're no longer building a transcode farm. You can use someone like SDVI or a Vitaspine. You're no longer building a QC farm. You just use SaaS partners to do this. And through their automation, you can be in any region, anywhere in the world. So really, it's about you focusing on what you do and providing this high-quality content to your users. So what's being built? We're seeing customers rethink things like disaster recovery. We recently talked to a large content provider that's doing play out in the cloud, much like Discovery. And they said, I don't know why I'm using another data center for this when I can spin this up in the cloud, and it can be sort of in standby mode when I need it. I can test it whenever I want. I can be in multiple regions throughout the world and have this play out come back to on-prem. Workflows, again, are also there to be cloud native in AWS. The other thing we constantly hear is that customers want to scale quickly. In their on-prem data center, they're sort of at capacity, and they don't have that ability to scale up for new shows, new programs, or to meet things on time. The other thing we hear too is they want to be geospatially diverse with their assets. One interesting story I always like to tell is when I was at Turner and a tornado came through downtown, hit the data center where our tape robot was. Of course, they had stuff on Iron Mountain, but it's just interesting, that here you can be really geographically diverse for those sorts of crazy stories like that. So the other thing you can do is you can really increase reliability and productivity in a modern media company. So next up, we have Hillary Roschke.
Thank you, Mark. Hello, everyone. My name is Hillary Roschke, and I'm the Director of Strategy and Process for the Global Technology and Operations Division of Discovery. For those of you who don't know, Discovery is home to more than 70 global brands. We include flagships like Discovery Channel, HGTV, Food Network, TLC, and Eurosport. Our content can be viewed across screens in more than 220 countries, and it's available in more than 50 languages. So I'm here because I've had the pleasure over the last few years to work with a small agile team whose mission was to build our cloud content factory. Our first task in 2015 was to migrate our incoming media processing and acceptance workflow to the cloud. These workflows originally varied by region. They all relied on physical media. They all relied on traditional shipping methods. They often had serial and real-time processing, and there were multiple manual touch points. While we worked to move the processes to the cloud, we also worked to unify, automate, and streamline them whenever possible. We received our first file delivery through the new platform in June 2016. By March of 2017, we had received our 10,000th file, and today we receive more than 10,000 files a month. The new cloud process is scalable, it meets demand, it speeds media availability, it improves content visibility, and it's highly available and reliable. So over the next 20 minutes or so, I'm going to provide some details about the problems Discovery was facing, the solutions that we chose. I'm going to share some high-level architecture of Discovery's Cloud Media Factory and the architecture used by our cloud orchestration partner, SDVI. I'm going to dig into workflows and the ways that we use step functions, lambdas, serverless elements in our workflows. And throughout, I'm going to discuss some tips and tricks that we picked up along the way. So the problem. Why rebuild a perfectly good content factory in the cloud? In 2015, we had regional hubs that were very busy, but every single one of them was running into 3 issues over and over and over again. The first issue was inconsistent volumes. So average delivery volumes would spike and drop daily, weekly, monthly. This could impact teams for periods of time. A long weekend, for instance, would give us a 4 times increase in deliveries. Something like Thanksgiving would have been awful. It was a 6 to 7 times increase before the holiday. Then the poor operators would come in Monday with a loading dock full of 4 times the normal volume just because the rest of the world kept working. We also had low volume issues, so the week between Christmas and New Year's was very hard to keep people working. Summer holidays would go down and down, and in fact, in Italy, the languaging houses closed for the entire month of August, so not only could we not keep people working, we were extra jealous that we weren't in Italy. So on top of this fluctuation and sort of inconsistent workflow, our hubs were getting an increase in special projects. These things required relatively high volumes of work to be completed in short periods of time, and they were always competing with the on-prem resources that were needed for business as usual work. Every project varied, requirements could be different, but a typical example was a late-breaking request for 2,000 hours of content to be processed within 1 month, supporting a regional digital offering. So these inconsistent volumes with the special projects exacerbated our problem number 2, which was multiple bottlenecks. I mentioned the workflows were serial, manual touch points. That also meant real-time processing through a finite set of resources. A good example of this is our Silver Spring, Maryland facility. In 2015, could only run 10 transcodes or conversions at a time. And this seems good, right? 10 hours of programming, churn through it. But when you think that every single piece of media that comes into the facility and every piece of media going out for a project needed at least 1 transcode and possibly a conversion, you could see where the backups would start, especially with those holiday peaks. I think the example of the 2,000 file special project is a good one here. It took 30% of the available transcode resources. So that left us only 70% to get all of the regular business as usual stuff. And you add a second project to that, you add the seasonal spikes, and you've got some trouble. That around-the-clock utilization of all of those on-prem resources led us to aging and overtaxed infrastructure as our third problem. Every single piece of equipment that supported this was on premises. So we have servers, we have converters, we have transcoders, we have tape decks, active file storage, and all of those things need to be maintained, refreshed, upgraded. That's expensive, that's time-consuming. Hope nothing goes down, but we're taking things out of rotation over and over again, which is just adding to our other 2 problems. So we looked at several solutions, but moving to the cloud gave us the most elegant solutions to those big 3 problems. Fluctuating volumes are no match for our flexible, scalable infrastructure that the cloud provides. Delivery peaks and special projects are handled just by spinning up additional resources. We could also eliminate waste. So before you're planning and you're provisioning for your worst days, and you're just accepting that there's underutilization the rest of the time. We don't do that anymore. We pay for what we use. Bottlenecks are also a thing of the past. So we're only currently eliminated by cost controls. And those are ones that we set ourselves. So we manage our queues with queue depth tolerances on different providers and things that we think is a reasonable amount of time to process content. If we run into those or we exceed them, then we burst and we spin up strategically, spend some money, get through the queue, and then we go back down to our base rate. And then the infrastructure is ageless. So our end-of-life servers and our broken components, not a concern anymore. At the first sign of an issue, and I do mean first sign, we monitor very carefully. We can kill anything that's not working. We can respawn single components or all of the components as we go through them in the supply chain. So now that we've discussed the reasons that discovery moved to the cloud, I want to look at the architecture a little bit. This slide is a high-level architecture of our incoming media processing flow. It's the supply chain that we have. So we have a vendor who would upload baseline metadata and attach a file, and that goes into our cloud environment through a homegrown tool called the Producers Portal. From this point on, Discovery is interacting with the AWS infrastructure through SDVI's cloud orchestration platform called Rally. And I'll give you a little more information on that in a second. Once in Rally, we validate that the file is what we expected. We make sure it doesn't have viruses, and if it's supposed to be video, it's a video file. Kind of high-level checks to make sure it can process through our ecosystem. Next, we go into an automated assessment. So some call this cloud QC, some call this automated QC. We just check the files, and we'll talk about that in detail in the first example. After that automated assessment, we transcode the files and we send them to the on-prem location. So an on-prem location is a little bit of a funny concept when you're talking about cloud architectures and what you're doing. Right now, in each facility, the media is automatically downloaded and checked into the regional MAMs, at which point people take the content and they do compliance edits, they do graphic reversioning, they customize for those regions. That is all work that will be moving to the cloud. So the next slide zooms in on the cloud portion of what I had just showed you, and this is an illustration of how Rally is interacting with AWS. So Rally is provided as a SaaS service, but it's single tenant. Discovery doesn't share resources with other customers. All our provider instances are our own, our S3 buckets are our own, and we can access Rally using AWS services like VPC, Route 53, and Elastic IP. Rally itself uses many AWS services, and those include Lambdas where appropriate. We've got image recognition and things we'll talk about in the second example. So more on that in a minute. Security level and layers. So we're very concerned about security. We wanted all of our content to live in our AWS accounts, in our buckets. We grant access using IAM, and sensitive data like usernames and passwords are stored with parameter store, and custom encryption keys can be used, might use KMS. Finally, the elasticity. So as workloads fluctuate, which is one of the reasons we went to the cloud, Rally's providing us that elasticity. It handles the access for traditional services using our controls, but serverless AWS services like media convert or recognition are provisioned automatically. So before I move on to the next example, I want to highlight an architectural principle that we hold near and dear to our hearts. We use step functions, and there's a recurring architectural pattern, I would say, of step function, heavy lifter, step function. We use these strategically to build simple but very powerful workflows. So step functions for us are interesting because we use SDVI's evaluate language in order to access them. That's an abstraction of the step functions. But leveraging step functions allows us to use what we know about a file in order to send it to its most optimal step in the workflow at every step in our supply chain. This architecture is a launch process evaluate. Again, it's a step function, heavy lifter, step function. We'll see where that fits into the architecture in a second, but that launcher does take what you know about a file to direct it to the best processor for it, the best heavy lifter, and the post-task evaluate confirms that the actions happened like we expected them to, and then sends it on to its next best step, or the file onto its next best step. So linking these functions allows us to simplify workflows. There could be hundreds of separate workflows that would drive this on on-prem MAMs, people choosing very specific things, using what they know about the file and all kinds of naming conventions that we've come to help them define what it is so that they can choose the right workflow. This drives efficiency for us. So we now have one linear flow. Don't laugh when you see it. It's a little complicated, but it's a linear flow. And it drives efficiency for us. It removes that complexity from the users, and it reduces waste. We're not wasting time by having the wrong workflow selected. We're not paying to process content more than once. So this eye chart is not meant to be read directly, but it is a view of the supply chain in the Rally platform. It's what we use to drive the incoming assessment workflow. And when we layer on top of it these circles, you'll see the pattern and how it's repeated through the chain. So we have blue ovals. Those are our launchers, the pre-task evaluates. Again, we assess the file. We look for certain key pieces of metadata that we use to determine what heavy lifter should be used and the right preset to kick off for that job. The orange ovals are the heavy lifters, transcoders, machine learning runs, what have you. And the black ovals are the post-task evaluates. Again, we confirm that the heavy lifter did what it should. We make sure that that was a valid action. We collect new metadata and aggregate that. We also normalize it, and we store it with the piece of media. And then we look for the conditions that will determine the next workflow step. So this is zooming into the top middle of that larger chart. Excuse me. This is the automated assessment portion of the supply chain. It's our Cloud QC or our AutoQC. In this specific example, the launcher identifies the video format and the file classification, file type for the piece of media that we're about to process. That sends it to the right preset and the right analysis tool, and then it initiates the work. During the processing, so the automated tool looks for technical issues with the file. It scans it and will report on high luminance, chrominance, out-of-phase audio, illegal audio peaks, anything that is important to you that you would like to know about your piece of media. The file then moves with all of the fresh new metadata into our post-task evaluate at the end. This evaluate checks for the codes from the analysis tool to determine the next step. In this step, we have three options. We will fail if there's a fatal error. We will fix it if there's an error that we know how to fix and have predetermined actions to take against, or we pass it on to the transcode and delivery. We include warnings and notifications, and that metadata does move with the piece of media, so it can be used downstream. So we have some code I don't have enough time to walk through, but on the slide, this will be available on the slide share. We have an example of the dynamic QC launcher, which is the first piece of that, the first step function, and the post QC evaluate code. So to recap this example, the repeating architectural pattern of our launcher, processor, evaluate, step function, heavy lifter, step function. It allows discovery to remove complexity from the operators and to streamline the workflows. This specific set of work that we just looked at, it takes dozens of individual workflows in the MAMs, dozens, and it replaces it with one scalable thing that happens before an operator even knows the file is coming in. It's automated, it's scalable, and it's customizable. The other thing that this gives us is the routing of content. So if we see that there's an issue with a file or we detect an issue with the heavy lifter, we can reroute. It also allows us to do the fixes, the self-healing workflows. It is much, much more efficient for us to run a legalization on a piece of media that has maybe high video levels than to fail it out, let a media logistics person know about it, have them contact a vendor. The vendor has to make the fix. The vendor then has to re-upload. We're paying for ingress twice. We're paying for processing twice. We can fix it in a matter of minutes, an hour at most. So we really, we find that to be a valuable addition for us. And as a rule, we code the response if we find a bad file condition more than twice. We also take a piece of the media that would trigger that and add it to our test battery and run it through our test systems as part of the work that we do every day. So our second example. This is an illustration of how Rally coordinates the flow of media through serverless tools like Media Convert and Recognition in order to generate metadata events that we use downstream. The launcher analyzes a file and it determines the appropriate machine learning tasks based on things like media deliverable type, language, deal type. When we do find content that needs a machine learning pass, we kick off a Media Convert job, and that makes a low-res proxy for us. That proxy is then sent to the appropriate machine learning tasks. Here we are actually running two independent recognition jobs in parallel. So at the same time, we are identifying things like cars, people, animals, things you might be interested in that are buried in that piece of video. And then the second job flags explicit content, so profanity, nudity. There's a very long list. The new labels, so it does the runs, we get all the labels, and that's sent to our post-task evaluate, where we take those labels, we map them to time codes, we tag them by type, and we save them against the asset. Again, this media or the information is available to the supply chain, so we can build more and more sophisticated workflows, but it's also available to any other downstream process. Here, we'll use the image recognition for things like pointing viewers to a car that we've noticed that they watch a lot, right? A type of car. Or we say, hey, this show has a lot of swearing. Someone should probably bleep it before we air it on a kids channel in Europe. It's very helpful. So this example, I think it showcases the power of the architectural principle. One of the tasks, it's one task, directing media where it needs to go, doing multiple heavy lift runs, aggregating all of the information, normalizing that metadata. And then I want to go into a little more detail about how that's used, because I think it's important. I'm hammering on the fact that it's available for the supply chain, and that's really valuable to us, but it's also allowed us to aggregate all kinds of information into one tool. We'll have one operator sitting down. They can look at a piece of media when it does need a human touch and a view, or if it's a high-value piece of content. They will view the piece of media, and they will see all of the technical flags from that first run in the first example and what time they are in the tool. But they can also see all of these other flags that we're adding. And we could add 10 other examples. There's really no limit about determining what's in the file, presenting a user with it in a way that they can filter and tag and sort out and just really make whatever they have to do to that content at that time available to them and really easy to filter through. So we've reviewed the discovery architecture and the SDVI architecture. We looked at a few examples with details, but I want to take a step back at a couple closing thoughts. Moving to the cloud is not painless, right? Serverless functions bring huge value, but it has tentacles and impacts through all parts of your organization. It's okay to start slow. It's okay to either take a little tiny piece of your workflow and move it all to the cloud, or maybe a small piece of a small function that you do and move that from end to end. Add where you need it, when you need it, as there's value. And also don't get too hung up in being in a hybrid. Serverless is not a religion. You can use it when it works for you. You don't have to. Don't feel badly about the hybrid models. And then even if you are moving fully to a serverless world, a cloud environment, your transition can be a little bit longer than you might want, right? You're changing your organization. Oftentimes people are going to have to live in two worlds. Manage expectations there. So this is going to impact people. It's going to impact budgets. But be aware that value and control over your supply chain increases the more mature you get and the more you add on there. So continue to drive that home to people. In terms of discussions, internal partners and clients might not be ready to move to the cloud with you. They might not be as excited or enjoy your timelines. Be prepared to talk to people about it. IT, operations, engineering, InfoSec, data. These teams could use some of the benefits that you're going to provide to them. Partner with them early. Change management played a really major role in the success of this first sort of migration that we did. And I can't stress that enough. Finally, monitoring and availability are paramount. I mentioned we watch things like a hawk, build tools that let you see the health of your chain, monitor components, know what you're going to do when something goes down, and deal with it very quickly. A very small problem, if left to go on for a little bit, can have bigger ripple effects that can impact everything that you're doing, and it might undermine some of the credibility you built with the people you just convinced to go to the cloud with you. So I think with that, I've reached the end of my time. So thank you all for your interest and attention. And Jaime, would you like to come up?
Thank you.
So my name is Jaime Valenzuela. I'm Director of Software Development at 20th Century Fox. And first, I want to give credit to our talented software development team for their dedication and contribution. Those guys there. I will share with you today how we came to use AWS Serverless for the digital media archive at 20th Century Fox to give you an idea of how you can migrate to serverless workflows to the cloud. I will start by giving you some historical business context for our media workflows and how we currently leverage microservices, how we migrate assets from our legacy systems, ingest new content, and restore assets for processing and distribution. I will show you how we use our own Stencil, Tube, and Stepper applications to manage our media pipelines in our facility. Our primary goal at the archive is to make sure that our digital masters are stored safely and securely, that we have a copy available even if a disaster hits our studio. Other goals include to leverage these masters to distribute directly to a customer or to send to another post-production facility. We also need to make sure that we can adapt to new formats and standards to remain relevant. We have a long tradition of asset protection and archiving at Fox, as we're one of the oldest studios in the world. Our first iteration digital media archive used an LTO library in our lot with a mirror in Wyoming. Ingesting and restoring assets from this system was programmed using BPM workflow solutions, and all that was hosted in our own data centers. Our data center, however, has limited expansion capability, and we continuously experienced power and cooling problems. On the application side, we found ourselves repeatedly coding the same functionality in C#, Java, JavaScript, even Perl. Some of these legacy solutions were really impossible to scale, and our existing SOA BPM solutions were difficult to maintain. Deploying to these legacy systems also required engineering resources and pages and pages of documentation to deploy. This system wasn't very flexible, and when it reached its end of life, we began to explore new alternatives in the cloud, and we began to put emphasis on cloud-native applications with serverless workflows. With Terraform adopted company-wide, we would achieve flexibility and consistency in our environments and infrastructure. But we also needed a mechanism to empower our admin and workflow engineering staff to create and modify workflows themselves without having to engage our development team. So our journey started with looking at Lambda functions to basically create an arsenal of microservices to reuse a lot of the functionality we had hard-coded in our legacy applications, and to leverage API Gateway to access those. And it would offer us basically limitless scalability. We would use DynamoDB collections for our data provider services. And since we had already been using Docker at our facility to deploy applications, utilizing ECS and ECR would make our deployments easier. The business then allowed us to look at S3 and Glacier as part of our archive and disaster recovery strategy. But the icing on the cake really came when we discovered the Elemental Media Convert service that would allow us to create proxies for every asset we had in the archive. And that would be like the peak demand, and we wouldn't have to spend a ton of money on licensing and building infrastructure just to create these proxies. So let me drill down into our media workflows for the archive and talk about some of our terminology. First, we define a workflow as a sequence of steps that needs to be executed to transform, catalog, or deliver the content. We create pipelines to optimize throughput in each one of these workflows. And we define jobs as instances of media running through these pipelines. Our facility runs 24/7 and executes hundreds of these jobs in a day. And so we needed to create an application to manage all these pipelines, and workflows. And that's why we created our tube application. And the pipelines themselves then are collections of orchestrated microservice calls using step functions. Our approach was to begin decoupling that common functionality into those reusable microservices. And we went a little further, and we chose Node.js to unify our front, backend, and microservice code into JavaScript. Our microservices can be grouped into two main categories: data provider services and computation or function providers. We use our data provider services to populate dropdowns or to match data fields with values like frame rates, ISO language codes, or audio configurations like 5.1 or stereo. The function providers do things like string manipulations, like parsing file names or extracting IDs from a document. They also do timecode calculations or frame rate conversions. Let me show you how our application stack is composed so you can get a general idea of our architecture. So at the top, we have those Lambda-based microservices that are accessed via API gateway and orchestrated with step functions. We created the Stencil application to render web forms on demand programmatically if required by a pipeline. And pipelines are created and managed in the tube application. The process to create a pipeline starts by defining what steps we need to orchestrate. But generally, we first want to know if user input is required to create a stencil for it. This slide shows you how the applications work together. So pipelines are defined and managed in tube. A stencil is a web-generated form that can be presented to an operator if input needs to be entered in the form. And submissions of that form or via API can create an instance of a pipeline in our stepper framework, and all the jobs are tracked in our tube system. This is kind of how we leverage this architecture in our digital media pipelines for the archive. So we currently have three main pipelines: migration from our legacy system, ingest of new assets that are coming in, and restoration or retrieval. The state of each one of these jobs in the pipelines is tracked in dashboards that we provide for operators to triage, retry, or resubmit these jobs. The restoration and migration pipelines don't need direct user input as they start via API triggers. That's how they come to us. But our ingest pipeline does require operator to enter data. And for those cases, that's why we developed the Stencil application and framework. And that will render that input web form for the operator programmatically. So let's look at that. So the Stencil application basically renders web forms programmatically. And that would allow like operators to enter like file media paths or select a codec or a frame rate. And we do that by basically either copy and pasting the JSON payload that we're going to submit to a service on the left pane, or we can query a WADL. And on the right, we have the different web components that can be assigned to that particular payload and presented to an operator. So a workflow engineer basically begins by clicking on a value of a key value pair in the JSON structure on the left. And that engineer is presented with options to type in a name for the group and a label to be rendered on that web form. And on the right, the engineer has to pick what element wants to associate with that particular field. So text boxes, drop-downs, checkbox, or some of the custom widgets we created can be selected. And that engineer can also attach validation to those fields. So we create basically a JSON object, a stencil object, that has a group, props, a validator, and a validation list. This is a sample of that stencil object that has basically an identifier and all the mappings for the JSON to the web form elements. So our Stencil framework then would render the web form and present it to the user, and this is an example of such a web form. So you can see we have a custom file browsing element, and that's where like an operator could choose media coming in, a video or an audio file. And then we have also drop-downs that can contain, in this example, aspect ratios to be selected by the operator. We also have autocomplete fields with language codes, our own time code widgets. Those are custom made, and checkboxes for them to select what kind of audio configuration they want to use. So these web forms can render in any step in the pipeline, and you can create as many as you need. So the pipelines are managed in that Tube application. That's where we keep a collection of all the different pipelines we have created in our facility. Defining pipelines starts with basic state machine definition in AWS step functions. So this state machine is very generic with steps that can be skipped or retried from our stepper framework via the Tube dashboard or some other dashboard. So we invoke an instance of this state machine when an operator submits a job by passing an execution ID and the payload data. And we create a new job record that we store in Tube for tracking. So our stepper environment object contains the unique IDs to track those instances of the jobs that are running. Step 0 that has all the instructions that are to be executed, the tasks to be performed, the parameters for the tasks like an ID or a key value pair that's necessary for the execution. And we also define if a step is to be skipped or not. And this is important because that's how we can recover. Let's say we have a 5-step pipeline, and steps 1 through 4 executed fine, and we had a network hiccup on step 5, but that was resolved. We don't want to redo the whole thing. So basically, we just resubmit the job and tell it to skip steps 1 through 4, and that's how we can retry only the last step without having to redo everything. We can also include optional mapper objects that basically obtain data from a step upstream, transform it, and pass it along to subsequent steps. And also, we can include optional flags to indicate a specific method in the controller. So we store these jobs, status objects in Tube, and that's how we track and allow the operators to triage and recover. The first section is how we identify each job. So we have a unique execution and workflow IDs, and the overall status of that job. And after that, we have the step 0 with all the instructions, and the result path for every step as it executes is then captured and stored in the Tube database and presented to the user as the step machine is executing each step. So let me zoom out and show you a dashboard that we built for our migration workflow that shows you that functionality. So in the Digital Media Archive department, we needed to first migrate our entire library from our current asset management system on premises to AWS and ingest into Vitispine, which is our new asset management system. So this dashboard that we created for our migration workflow can track the status of every step in the pipelines as they run. And operators are able to retry or resubmit from any step. No user input is required in this workflow because we're basically just iterating through every single asset in our old system and migrating it to the new one. But let me show you the new asset ingest workflow in a little more detail. So when we get a new asset and we need to ingest it into the new system, we basically reuse a lot of the same steps that we use for the migration, with addition of some other steps that are required because the assets are brand new and we don't have all the data. The old system basically captures all the information already in the database. So when that new asset comes in, we basically need to add that new information by presenting a stencil-generated web form to the operator. And when the asset is received, and submission of that form will then create the ingest job instance that will ingest the new asset into vDespine. That pipeline consists of first creating a bundle, like getting a 5.1 set of audio tracks and making a new object with all those tracks. We validate media using Baten, and we invoke that via API. We also generate the checksums and extract technical metadata on the files themselves using media info. We have a strict file naming convention at the facility, so that also needs to be verified and validated. The digital vault operators are also required to spot check the media itself, to take a look at the content, to make sure that we're not ingesting Deadpool against Alvin and the Chipmunks. vDespine agents take care of storing the assets in our LTO library as well as copying to S3. And when that S3 copy completes, it triggers a proxy workflow that uses the Elemental Media Convert service. And then assets are able to migrate to Glacier according to policy. Let me show you the proxy workflow in more detail because it's pretty cool. So we have to create proxies for every single asset that we have in the archive so that anybody can preview the media and find the content they need easily. And these proxies are created when the upload to S3 completes. So proxy jobs are queued in SQS, and a consumer then posts the job request to a Lambda service to invoke the Elemental Media Convert job. When the proxy job completes, we have to attach that proxy media element with the original asset entry in vDespine. Then the media is able to transition to Glacier, and the ingest is complete. I'll show you quickly how we manage the restore workflows in our facility. The restore workflow is pretty simple because basically we're just retrieving the media and moving it to a new location, either on premises or delivering it to a post-production house or a customer. And those requests come to us via API. So no user input is required from our system at this time. And that happens upstream. So that API request comes in, creates an instance of the restoration pipeline. And that job is pretty simple and it's tracked. It only has like a handful of steps. And we display their status to the Vault operators with this dashboard so they can triage and retry these jobs from any step. To wrap it up, for our team, creating a microservice collection using Lambda and API Gateway was the way to go. It was simple, and it would give us probably the biggest bang for the buck. And we realized that attaching DynamoDB collections to the services was very easy. It was super straightforward. Step functions did provide us the way to orchestrate this service calls, but it did take some development cycles to be able to support our hybrid on-premise and cloud-based workflows. So that wasn't trivial to make it work on both places, or in our on-premise systems and cloud. But using this generic state machine paradigm was very, very advantageous because we could use it pretty much anywhere. So that made it very reusable. So we recommend that you look into that. We're now beginning to focus on creating a user interface for admin and workflow engineers to define and basically connect all those different orchestration calls themselves. So right now it requires a developer to be involved, but soon, hopefully soon, we'll have some kind of a user interface where they can take care of that themselves. And we're beginning to explore deploying our containers to Fargate, and we need to compare the cost of deploying to Fargate versus deploying to our EC2 instances like we do today. Thank you.